Well, welcome back to the Azure Podcast. This is episode number 482, being recorded on the 21st of December, 2023. Today I'm here with Evan and Cale, and we're going to talk about the Network Watcher, which is a feature in Azure which I think everybody should know. And we haven't given too much of love to that service on the show before, so we figured it's about time. Just so happened that I've had to dig into Network Watcher. Evan's been helping me out as well this week, so figured let's share our findings with everybody else so that others can take advantage of this great service. So Network Watcher it is for today. But before that, let's get on with some news. Evan, I think you had some news from last week
Yeah,
that you didn't
uh,
cover, and
yeah, a couple of retirement related stuff, and then some new features and capabilities. But from I don't know, retirement may not be the right word for this one, but TLS 1.3, which by the way, if I slip up and call it SSL, it's not SSL anymore. That's just what I always call it. But TLS 1.3 is coming, right? It's been around for a couple of years now, but it's 1.1 and 1.2 are increasingly less prevalent, and so 1.3, there's a bunch of work going on to make that default in a lot of places. Most of the modern OSs and devices and everything support it, but a number of the Azure services have been providing the capability to, for some brief window, you know, turn on or test against 1.3. And Application Insights is the latest one to add this capability. I definitely recommend anybody that use Application Insights, turn it on for a little bit, see what fails, right? Or within your logging, look and see what's failing. Because again, it's better to find it out now when you have control than at some point when 1.1 and 1.2 start dropping off, which 1.1 has absolutely started dropping off, right? And 1.2 is starting to. The other one, and I sort of have to laugh because it makes me feel um, like this wasn't that many years ago, but it feels like they've been around forever. But the Azure VPN standard and high performance VPN gateway SKUs, which were the old classic um, uh, Azure Classic based VPNs. These are getting retired in 2025, September of 2025. Again, if you're creating new VPN gateways these days, right, you really have to work to opt in to these. So it's not likely to be, but a lot of people that have had VPN gateways for years are potentially running on these older SKUs. So you should definitely be looking at migrating over. I think we have some capabilities. I can't remember for sure to help with the migration, but there is definitely a possibility, depending on what you're running, you may have to take some downtime and delete them and recreate them. But again, better do that now than as we get closer and closer in 2025. This is actually, and I'll mention here, although we don't have a link for this, but Azure Classic, right, is on a deprecation path, has been there for a couple of years. We actually fully deprecated VMs in September, I think, of this year, just a couple of months ago. And now all the services that are built on that are starting to retire their older SKUs. So it's actually a really good thing because now everything's going to be ARM based. You get all the zone redundancy for free. All that kind of stuff comes with it. The Azure Chaos Studio, which is again a great tool when you're building your apps for testing their resiliency to failures. There's some new capabilities for service bus faults. Basically, when you see topic changes or queue changes, right, you can test it dynamically or get Azure Chaos Studio to basically replicate that and see how your app behaves. I think we had Chaos Studio on the show, one
yep.
one time last year. I cannot recommend strongly enough people check out this service, right? It's you don't want to find problems in your deployment once you're in production, right? You want to find them ahead of time, and it's a great way to do it. The last one I want to reference, and this is of a little bit of personal interest because my mom for a long time was in this industry of digital imaging for healthcare stuff. But there's a service. I actually had to go look this up. A service called or a standard called DICOM, which is Digital Imaging and Communications in Medicine. And I've got this in front of me because I did have to go look this up. But this is basically a standard for the storage and transmission of medical images, right? So the HIPAA related stuff, and need to make sure this stuff is secure and make sure it's shareable between all the different vendors and types of systems that are out there that manage these images. But we have a service that allows you to implement this standard, but now we've integrated Azure Data Lake Storage with the DICOM service that we have as well. And this allows you to basically store your images in this big, massive data lake at that point, and then again leverage it with the downstream services. So this is all part of our health services features and capabilities that we're launching. At some point, we probably ought to do a show on this because it's a pretty good collection of this stuff that's out there now. But this is all sort of expanding those capabilities and allowing medical providers to run on the platform in a safe and compliant way.
Yeah, it's funny you bring up the DICOM stuff. I worked on that stuff like way years back in early
Really
2000s.
funny.
And
Okay.
it's not insignificant, right? It's not like,
Yeah.
oh, well, there's a different type of file format here, we're good to go. No, it's way complex. Like there's a lot into this, so I don't want to like belittle this at all. That's a pretty big achievement, to
Yep.
have that in there, because that's that protocol is quite vast, as you can imagine. Like it's for like, X-ray machine talking to another one and these kind of things. So it's it's quite complex. Yeah.
Yep. Yeah, it's bad. I mean, you think about all the challenges we have, exchanging, spreadsheet files, right, between different formats. Like you can imagine the challenges when you're trying to do medical care, right? And you get the X-ray from company X and it's being viewed by company Y. Like all that stuff has to be intercompliant at that point, or interoperable at that point.
Yeah, I've got a quick one over here. This is related to Azure SQL. So we know the Azure SQL PaaS service is something we've had for a while. And there's also another service called Azure SQL Managed Instance, right? Which is kind of on top of the PaaS service. It adds things like, managed updates, backups, etc. of your service. Now, typically, it's been quite expensive to try and get onto a managed instance service, right? Because that's sort of more dedicated for you, right? It's not a shared service as such, and customers are reluctant to get onto that because of the cost. Now there's a free offer where you can have your own managed instance, one per subscription, which allows 720 vCore hours for the month, which is basically a single core you can run for the whole month, and 64 GB of storage, of which about half of that will go to actually install the all the files, system files and whatnot. So you'll get about 32 GB for your data, but with that you can have that for the month, and it shouldn't really cost you anything. And this allows you, if you want to try out managed instance, make sure that it does work for you for your development project that you're working on, and then later on you can kind of sign up for it and use it in production if you want to. Or if you just want to kick the tires and see how it is, compared to your own on-premises SQL Server that you may have, right? Because that might be the next logical step when we go to managed instance. So I think this is a real nice offer for those for folks that are reluctant to try it out because of the cost.
Yeah, I love managed instances because SQL Azure or Azure SQL DB is really sort of the ultimate end goal, but there's still lots of scenarios, especially when you're talking about cross database things and some of the more complicated transactional replication stuff that you just can't do with Azure SQL DB, and managed instances is a great stepping stone, right, from having to run it yourself on a VM, right? Like it's a great place to start. Yeah.
Great. All right. So maybe we can get started on our topic today, topic du jour, which is Network Watcher. Right. I think we've probably mentioned the word Network Watcher in passing 1,000 times on this show, but never actually dug into it. So I'm glad we're spending the time today to do it. I guess at a high level, I would say Network Watcher is a network monitoring / diagnostic tool available in Azure, right? One of the problems I shouldn't say a problem with Azure, but one of the concerns that customers may have moving from on-premises to Azure is that you lose control over some things that you had on-premises, right? One of the things you lose control of is you can't really touch and feel the network anymore like you used to, right? You get this thing called a VNet, but you can't, you feel like you can't do much about it. Like if you have to, we have all these tools that we use to running in our own network, things like, Sniffer or, all the diagnostic tools that we have at our disposal. And we don't necessarily have that in Azure. And so I think Network Watcher is a nice set of tools, like a toolbox, which gives you some of that capability inside of Azure itself. Evan, I'm sure you're close to Network Watcher. How would you characterize it?
Yeah, I mean, I think your characterization is right, and I think I won't push back on the problem statement because that you started with, because the reality is, networking is a complicated area, even on premises, right? I made a living debugging that kind of stuff, and it has gotten easier to manage in a lot of ways, and there's a class of problems that are gone, but it's still a non-trivial area for sure, right? And so Network Watcher, it's funny. I really love the service. I think it brings a lot of capabilities in terms of diagnosing common scenarios. But it's also the one that when you and I, you were pinging me about the other day. I'm like, I'm not sure. I haven't ever looked at it because unfortunately, while we recommend it to customers all the time, I don't know a lot of customers that use it, and I think that's really to their detriment. I mean, I really do recommend people check it out and install it, especially some of the agent-based monitoring stuff, because it'll detect and tell you about things, right? And so that you can react to them ahead of time, and you're just, I think, missing a potential opportunity if you're not leveraging it. It's
The
not a show.
interesting
It's
thing,
not a show if we don't have a mute issue.
exactly. Network monitor is kind of it's a regional service, so
Yeah.
essentially if you've got multiple regions that you're using in Azure, you'll need at least one instance of it per region. Okay, so in my case, I just happen to have services across 3 different regions in the US, and so I wound up with 3 instances of Network Watcher. But the features that Network Watcher has, right, loosely fall into 3 buckets, I would say. One is monitoring, the other one is diagnostic tools, and the third one is logging, right? And so these 3 are the broad areas that it falls under. In the monitoring area, one of the features is which is very cool, is where it draws out a topology for you, right? It creates a network diagram, so to speak. So it kind of gives you an insights into your VNet, what devices are connected to it, what sort of energies are being applied, like just visually, right? It's like a Visio diagram or such that shows you how your network's laid out, which I think is a very useful thing, because you don't realize how much stuff you have on the network until you actually see it, right? Like, oh my God, look at the number of devices that wound up there.
Yep.
Then kind of the next step on into the monitoring is just being able to monitor connections or connection problems in Azure is something that most customers want. I know that was something I was
This is
certainly
what you
looking.
were trying to set up yesterday, right?
Exactly. And this is where I feel like Network Watcher Azure has gone through some maturity in this space, right? There's been a number of tools which I think are now starting to be deprecated, and there's some, I think, this documentation could probably use a little bit of work in terms of being clear on what the correct tools are. But as of now, I believe if you want to do good monitoring for VNets, you use a tool called the Connection Monitor, right? That is the current sort of supported tool, which if you're starting today, that's what you would use, the Connection Monitor. And that is a really nice tool, because what it lets you do is, it solves this canonical issue with the networks, right? I have a VM A and I have a VM B, and they're trying to connect to each other over some port maybe, or something like that. How do I make sure that that connection is always up? What is the latency of that connection? Is it running slow? Things like that, right? Because latency is kind of the biggest or the earliest problem that you would look into when when things start going wrong in Azure, right? Moment latency starts suffering, that something is going to happen. Something's going to go down soon, and so keeping an eye on latency, especially network latency, is a key feature. So that's the one thing that Connection Monitor does. It kind of lets you say, okay, from this VM to this VM on this port with this, kind of protocol or whatever. I want you to monitor the latency between these 2 endpoints, and it kind of sets up a job. As Evan said, there's agents on each VM that would start sort of pinging or talking to each other and recording all of the latency metrics that were created.
The other thing that's nice about this, and there's certainly some some theoretical downsides with an agent-based topology. But in this case, what this brings is you can actually include your on-premises side in this, right? You can actually run these agents on on-premises resources as well, which gives you the ability, so again, there is some complexity that now you're installing something in the guest, which you have to be, cognizant of, and your security team has to be on board with and whatnot. There is some niceness about some platform feature that I don't have to do anything like that, but that then becomes limited. Sort of like Azure Arc in that sense, right? Arc, by being, multi-platform in essence. And I assume, I haven't actually checked, but I would assume since Connection Monitor is just agent-based, you could probably do it across AWS or Google Cloud as well. It's just data at that point. But like, it gives you the ability to really see your whole network and not just the narrow slice that you have in Azure, because very few people just have Azure, right? There's all these different pieces that go with it.
Right. Yeah, as long as the agent can call home into Azure, I suppose it should be able to be deployed anywhere.
Yeah.
But yeah, so Connection Monitor, again, there was an old classic Connection Monitor which has been deprecated. There's also the Network Performance Monitor, which is being deprecated. So there's all these tools that are being deprecated. So we're all gravitating towards this thing called the Connection Monitor. And so that's the one that, or the new Connection Monitor, and that's the one that we should be using if we try this feature. Well, the nice thing about graphing the latency is that you can now set alerts for that latency. So that's the key point here. It's like you want to know when the latency goes over a certain baseline number. Let's say your baseline at 10 milliseconds latency between these two servers. Now you can start setting up alerts. If it goes beyond that for an extended period of time, alert me, because that's probably an indication something's going to go wrong soon.
Yeah, it seems like on the proactive side, like what you just described, Sujit, makes a lot of sense. I guess I have some questions maybe for our listeners on Network Watcher. So for instance, if I have some infrastructure running in Azure, I assume I have to opt into this thing. And what does that mean, right? Like, do I enable, like, how can I, if I don't even know, like, I'm going to diagnose something tomorrow. Usually when I'm diagnosing something, it's probably something unexpected, right? So is there something I should be as a best practice? Hey, when you put VMs in a VNet, you should turn this thing on and you won't have to pay for, like, I don't know how the pricing and all that works, but like, is there something that should be like in the background running there so that when I need it, I can go to it and then I can pay for what I need? Or how does that work? I don't know.
I'm actually not familiar with the pricing structure for Network Monitor, which I probably shows where I focus on this stuff. We can probably point to some links on it, because I'm sure it's not zero, right? There's probably some incremental cost. But to your question about sort of, is it not really, it's worth it? But if I sort of take your question and reframe it a little bit, like, there's always this balance of, do I spend money to have the data and the telemetry I need to debug something? And I personally, again, I come from the world of things being broken all the time, so maybe I'm a little bit biased, but these types of tools generally are not expensive enough, in my opinion, to justify the fact that when you need it, you need it, right? Downtime's super expensive, right? The last number I saw was like $9,000 a minute to large customers, and so, I think for the alerting that Sujit was talking about, yeah, you absolutely need to go ahead and do that ahead of time. But there's a whole host of capabilities within Network Watcher that are on-demand capabilities. Like if you have a problem with an NSG, if you're having problems with your routing rules, if you can't get from VM A to VM B, you can actually, and I love this feature because it's actually really unique in that you can do what's called IP flow verify, which basically says, can I get from A to B? But it's not just looking at the traffic rules that you've set. It actually initiates a flow or a set of packets to make a connection. And so if you have, I don't know, something going on in the guest that's blocking these packets, it'll tell you, it'll say, hey, I got through all the NSGs, I got through all the pieces, but then I didn't actually get a response back from the guest, or I got a partial response. All those things, the NSG stuff, the next hop, the VPN troubleshooting, all that stuff you can do on demand, sort of on the fly. So it's sort of a hybrid of both of what you're talking about. But for the the preemptive monitoring, like Sujit was talking about, yeah, you absolutely have to install that ahead of time. Like you can't get the data after the fact because the agents aren't there. But it's a mix of both.
Gotcha. I see these. I don't know. Maybe this is a lot of context, but I see these. Like if you use our portal to go provision like VMs and stuff like that, immediately you'll see this network watcher thing, resource group get fired, and I was like, interesting. I guess that's just in the background enabled.
Yeah, and like I was saying, Cale, it's basically it creates one per region. That's kind
Yep.
of the default thing.
Yep.
So every region that you happen to, so if you deployed a resource for the first time in a particular region, a network watch kind of resource is created for that region, right? Now you
Nice.
can later on you go and delete it if you feel like I just don't want it. There's no cost to having this the network watcher
Enabled.
service enabled for the region.
Yeah.
The cost is if you use each of the individual features. Like I said,
Gotcha.
there's monitoring. So the monitoring involves setting up this connection monitor, which has a bunch of tests that you do in it. And then, for running the test, there is a small fee. I just saw it. So there's a fee per test that's included. I think it's like a few cents or something like that. Similarly, if you use any of the diagnostic tools, it's some nominal fee for using the diagnostic tools. And then if you do the logs, obviously logs, it's going to have storage costs and all associated with. So that's kind of there. You kind of sign up for all of that when you use Network Watcher. But just for keeping it on your service in your region, there is no cost. Now, Evan already mentioned IP flow verify, which I think is the kind of the first tool that you would use if you have a specific IP that you want to see. Why can't I get somewhere from this IP, or can I get to that IP? That's a good way to check it out, and it essentially tells you if there's an NSG, a network security group, that's blocking your access, right? Another tool that they have, which is kind of, I would say, the next level from IP Flow Verify, is NSG Diagnostics, which is another tool which is in Network Watcher itself. And that gives you a little more broader view, okay, saying, from this side of range, if I were to try to connect to this IP, would it work, right? Would something block? Now you're looking at more like what if analysis, right? What's going to allow or not allow that flow? And so again, it's going to look at the NSGs, and it's going to say, okay, it's going to be allowed because these energies are set up in that way, or it's going to be blocked because of this deny rule in this specific NSG here. So those are kind of in terms of actual, looking at IP flow, that I believe is those are the two primary tools, IP Flow Verify and NSG Diagnostics. Now there is another tool which is called Next Hop, and that is, again, very simple thing where it says, okay, I'm here, and if I go to that destination, what's the next hop going to be? Is it going to be this router here, or maybe there's an internet gateway or something like that gets involved? So that's what Next Hop is going to do, just to give you that additional detail about where this packet's going to go next.
Yeah, that one's I like that one too, because again, I spend a lot of time in this space, and even I struggle to read all the routing rules and sort of reconcile all the different pieces and come up with, yes, my next hop is definitively this place, right? That's really easy to do incorrectly. Next hop's great. It just resolves them for you and tells you what they're going to be, right? Which is super handy. Yep. Much more reliable than us humans at that exercise.
And I think it's fair to say that NSGs are kind of one of the things.
By the way,
that most people
network security groups for customers, for somebody, because I don't think we mentioned that.
That's correct. Yeah. So these are kind of almost like firewall-like rules that you can apply on your VM, on the subnet, et cetera, at different places. And one of the problems is that when a packet has to flow through the system, it flows through multiple NSGs, right? For example, from a VM, it first the NSGs in the network interface get applied. Then the NSGs on the subnet would get applied, and so on and so forth. And then again, if it goes to another network on the destination side, again the same thing would happen there. It would apply on that subnet and then destination VM as well. So the problem is you never know where where it's breaking, right? Nobody knows, and so there's this nice feature called effective security rules, right? So again, you kind of provide the machine and the network interface and it looks at that, combines it with what's available on the subnet it's on, and tells you, okay, in aggregate, this is what this effective security rule is going to be, right? It kind of gives you like a combined collapsed view, as opposed to you having to figure out each hop where the deny or allow assignment is. So I think that's another useful one, is using the effective security rules option in the Network Watcher.
One question I had is around how invasive this is for customer environments. So, to my knowledge, and correct me if I'm wrong, like there's like an agent that could be used as part of this specifically for things like VMs when you're testing like end-to-end type things, and there's actual something like an agent that gets put onto VM to do that. But in most cases, are most of these tools like external, like basically you're using them, but it's not really changing your environment in any way, configuration-wise or any of that kind of stuff, right?
Yeah, the diagnostic tools are primarily looking at your network setup and all to figure out, if this packet would flow. I think the IP flow verify, as Evan said, that one actually sends kind of a packet through. But things like energy diagnostics, next hop, effective security rules, that's kind of analyzing your NSGs to figure out where the problem might be.
Gotcha.
So for that, you wouldn't need the agent. And then kind of another feature I know I used a lot when I had my own networking set up here at home to have like a hub and network cables and whatnot, is running a network capture, right? Running something like Wireshark or Sniffer.
Wait a minute. You can read network capture, Sujit? I'm not judging. I just didn't realize that. I'm gonna send something.
Oh yeah, yeah. I spent many
I did not know
years
that.
reading network captures. Yep, all the protocols and everything. Yeah, I can, especially when it comes to HTTP and TCP traffic. Yeah, I spend a lot of time with that.
Okay.
But so sometimes you feel like you need to do that here, right? And you just can't plug in a Wireshark device and do it. So there is a packet capture feature that's available in Network Watcher now. We could say, okay, I want to create a packet capture between these 2 points, and then kind of creates that network dump for you, so to speak.
This is the other feature that I really love, and unfortunately, it's way underutilized, because what's nice about this is, so it's an agent-based packet capture, and the agent actually, I can't remember if it natively dumps them to storage or it collects them locally and then it copies them over to remote storage every so often. But you can do all of this without having to remote or SSH into the virtual machine. And like in the world of so many people still doing manual touches on their production servers, I really would love to see more people adopt leveraging capture or collecting capture packet captures. I can't say the word today. Collecting packet captures using a no-touch mechanism, right? Rather than, and hopefully they're jitting into these virtual machines. But again, I see lots of people who aren't. They just have credentials. They log into them and then they collect it. That's just such a riskier thing at that point. Not to mention you sort of risk, filling up drives and all those kind of complexities that can happen as well.
Yep.
And then we send it to Sujit to go analyze at that point.
Yeah, you're right though. You can store it to a storage account, to a file, or to both. So you have all awesome. 3 options there. But yeah, that's certainly something that's in your toolbox. And sometimes you're just not sure which of these tools you want to use, right? Because it's many tools that we talked about, but you may be walking into a problem and like, which tool should I start with? So there is something called the connection troubleshooter, which is another tool in the Network Watcher, which kind of aggregates all these tools. It says, I'm going to try all of them and give you all the results. Sort of, if you're not sure which one to use, you could try the network troubleshooter. So that's connection troubleshooter. So that's your kind of catch-all tool, if you ever need to track down a problem. And then finally, we move to the area of logging, right? Because there are some times when you just want to log network flows over time, right? Maybe you want to figure out, am I getting a lot of traffic in this direction? Are we getting a lot of errors in that direction? What's happening, right? Are people trying to come in and it's just getting blocked all the time? And so there's this option of flow logs. So you can create flow logs between, again, between two source and destination. And again, there's a log to a storage account. You can go back later and figure out, what are the trends, what are we seeing in terms of these flow logs. There's an additional feature of flow logs called traffic analysis, which is a kind of even more detail is stored, and there you could kind of log things like which region customers are coming from, these network traffics are coming from, to kind of figure out if you have a regional distribution issue. So those are flow logs. And then finally, you have the traditional diagnostic logs, right? And these are like at the NIC level now. You want to say, okay, this NIC is misbehaving. And, we've seen these being used for things like VNet encryption, or, we have some of the very low level network issues. You can turn on diagnostic logs at the interface level itself, at the network interface level. And so that feature is also available to you.
And I like the other thing I like about the traffic analytics is it takes all these logs and it aggregates them for you, so it really does reduce, like, you get all the detail without all the complexity, right? Because think about every TCP connection is a flow, and so we're logging every flow. Like, you don't want to have to look through all of that and figure out that aggregation yourself. So yeah, it makes it a lot easier to think about that.
Yep. So yeah, I strongly believe if you use virtual machines, right? I believe using things like the network watcher is a required tool in your belt.
What, just out of curiosity, Sujit, what were you debugging yesterday that required you to look at this? Let's talk about a real world situation. Is that something that you can share, or were you just playing with it?
No. So we're essentially trying to figure out when a virtual network starts misbehaving, right? They said virtual networks can misbehave because the VMs that are connected to it are not working correctly. Maybe there's application problems, but there could be also problems with the virtual network. And looking at latency of the virtual network is something that I thought would help identify when something is potentially going bad, right? So that was the main draw for me, is like, how do I monitor the latency between multiple endpoints on that VNet? And if the latency starts increasing over baseline numbers, then you can start thinking that, maybe there is a problem. The problem could be on the VM, could be with my application. Maybe I don't have enough CPU or memory, and the application's gone really slow. That's one problem. So you got to rule that out first. But assuming you can rule that out, and then you're still having the problem, then that could mean that the VNet itself may be having problem. Maybe there's packet drops on the VNet. At that point, things are being retried multiple times. And so that's why latency tends to be a nice catch-all kind of metric for all of those problems, right? And quick, then you kind of have to kind of drill down specifically where the issue may be once you've identified that there is a latency problem.
Yeah, and this is a good example of where, while software-defined networks, so cloud, this is what cloud does, and I guess you do SDN on premises as well these days, but like where it adds a ton of complexity, because in the on-premises world, everything you would get a trace on is typically either a physical device or it's a virtualized equivalent of it, like a virtual machine, right? But in Azure, the VNet actually, and this is why I was asking sort of the scenario, your virtual network is actually not a thing. But what you're talking about in that context as the virtual network is really the collection of the software load balancer service that we have, the actual host, right? That's because really, if I'm going from VM1 to VM2, I'm actually going for my flow to get initiated, I go through the software load balancer. But after my flow is initiated, I'm going VM to VM in most scenarios. So it's sort of host to host in that case. Now, you might go through a gateway if you're going across, but even going across VNet, you're still going VM to VM. We just apply different rules. But by having something like that, the connection monitor in place, it can tell you some of those pieces that are really hard to figure out, because again, it's completely abstracted for you, right? And so that's the other reason I really love that tooling, because it it really does help you narrow in on some of these complicated pieces that are, by design abstracted from the end user.
And I'm glad you mentioned that, because there are these, they call them T1, T2, and even T3 devices in the data center. That's what you're referring to, and they are documented. I will put a link to that. There's a nice page on the Azure website that talks about them, but unfortunately, we don't get insights into where the problem is in these various tiers, right, within the data center. And so we're hoping that this latency metric will help us kind of drill down into that area.
Yeah, we absolutely. So there's a version of this tool that we use internally to debug some of this, where we're actually at the host level. So right at the interface between the virtual machine and the physical, basically the VM switch layer, we are sending packets to all the virtual machine switches in your virtual network. And so we actually have metrics that we look at, trying to say, hey, what does that look like? Because again, if that looks healthy, then any problems are probably coming inside the virtual machine. If that looks bad, the virtual machine can't really impact that, or not generally. If the virtual machine looks bad, then at that point, hey, I'm sorry, if that data looks bad, then the problem is probably below the stack, right? It's one of the physical devices, or it's the T0 or top of rack switch, right? Like that helps us narrow it down as well. And so that's actually, I remember the conversations when they were building these features into Network Watcher. A lot of them came out of the same troubleshooting tools that we used internally that provide a lot of insight, but like there's just not, like we had to really work to figure out how do we expose them to the customer without exposing too much complexity.
Exactly. Yeah. That's very good insights. Thanks, Evan. All right.
One question I had too that maybe kind of goes without saying, it might be a dumb question, but I'll ask it anyway for our listeners, is we talked a lot about VMs here, right? And generally we don't do a lot of work with VMs in the current world, right? We use Kubernetes, we use all kinds of other things. So how should people think about that? Because for me, being naive for these tools, it's like, well, I could diagnose stuff at the virtual network, the gateway level, the application gateway level, those kind of things. Mm-hmm. But maybe the PaaS service doesn't, right? Because I don't have access to the VMs at that point. Is that the way people should think about it? We can still use these tools. We just use them differently, because it's not like we're actually interfacing with a VM, kind of thing.
Yeah, I actually don't know. I know a lot of PaaS services you can't leverage it, like Azure SQL DB, Postgres. Those, App Gateway and some of those you can, because they're sort of integrated into the network stack. But I don't know, Sujit, do you know, can we use it with containers?
Yeah. With the AKS, when you deploy AKS, as you know, it creates a shadow resource group which has the actual VM scale set in it, right? So the VM scale set is clearly there for you, and the NICs are all there for you to see.
So it would be at the AKS node level, but not at the container level in that case,
correct.
Right?
The container level is more like a software networking stack inside of Kubernetes. Okay. But you can still go to the VMSS node itself, look at the NIC card, and then apply the same kind of logic there.
Nice.
All the rules there.
That's awesome. Yeah, thanks.
Yeah. Sure. All right. Well, thanks. Good questions. And if I don't talk to you guys or everybody else listening in, happy holidays, and we'll hopefully get you in the new year.
Yep. See everybody in 2024. Thanks, y'all.
Thanks, guys.
Take care then. Bye.